Hello, let's continue our Sudoku adventure with Oachkatzlschoaf by Palfly Kampling. So we have normal 6x6 Sudoku rules, meaning in every row, every column, and every 2x3 box, we are placing the digits 1 to 6 exactly once each. This squirrel's tail here, which is what that word means, I'm not trying to say it again, is actually a German whisper line. So the reason it's colored that way is because of the squirrel theme, but it is just your normal German whisper line. It's squiggly also, but just pay attention to what cells it touches. So it hits these cells, right? So it is a German whisper line, which means that adjacent digits along the line have to have a difference of at least 3. So if this was a 2, right, this could be a 5 because 5 minus 2 is 3, but it could also be a 6 because we just need to be at least 3. We can't be as a 4 or a 3 or a 1 because that difference is not at least 3. Order doesn't matter. So if this was a 5, this could be a 2. In addition to that, we just have this single V in the grid. These two digits sum to 5. V is the Roman numeral for 5. And that's it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself. And I'm going to get started right now. All right, I am not above putting 1, 2, 3, 4 here. 3 and 4 are a bit special in German whispers in 6x6 because 3 can only go next to 6 and 4 can only go next to 1. So if this was a 3, for example, this would be 6 and this would be 6. If this was a 4, this would be 1 and this would be 1. I don't see an immediate reason that that can't be true though. So we have to leave that in as an option. So what I'm going to do is I'm going to color these because there's a property of German whispers that is preserved across all grid sizes. So it's true in 9x9, it's true in 6x6. And that's why the difference is different between those two. But anyway, what it is that it always swaps between low digits and high digits. Now, what constitutes a low digit, what constitutes a high digit is going to change based on grid size. But in 6x6, a low is going to be 1, 2, 3, and a high is going to be 4, 5, 6. So if you imagine we start with a 1, 2, or 3, we cannot subtract 3 from that. That's going to be 0 or lower. And so we're going to have to add 3. And when we add 3, we get out of that 1, 2, 3 range and we enter the 4, 5, 6 range. And then once we're in 4, 5, 6, we can't add 3. So we're going to subtract 3 and that gets us back to the 1, 2, 3 range. So I don't know which one's low and which one's high, but I do know they alternate. So I'm going to use green and purple to show that alternation. So these are green and then every other here. Green, purple, green, purple, green, purple. These are all purple. So the greens are all they're either all low or all high, and the purples are either all high or all low, depending on situation. Now we know that there are 3 lows and 3 highs in every row, column, or box, so that might help us as well. So for example, this column here has 3 greens. It only has 2 purples, so it needs a third purple. That's going to go there. Now this row has 3 purples, so it needs 2 more greens. This box has 3 greens, so it needs 2 more purples. This is just going to be purple-green. We don't know the order yet. Can we do any more coloring here? I'm thinking about this adding to 5 thing. 1, 4 swaps, 2, 3 stays. So we don't really know yet how that works. If we could prove this was purple or green, we would actually know whether this was 1, 4 or 2, 3. But this is one of each for the column. Trying to see if there's any more coloring I can do here. We know this is one of each. I'm not sure we can color more at the moment. Okay, if there is a way, hopefully I'll notice it later. The other thing that I want to talk about, which I kind of briefly glanced on, was 3 and 4, right? So what would happen if I tried to put a 3 here, just as an example? Well, the only digit that can be next to 3 is a 6, so this would be a 6, but also this would be a 6. And that clashes because these two are in the same column, right? So we might want, I think we do want to go through and figure out which of these can actually be 3 or 6. So this can be 3, 6. This can be 3, 6 because it would affect these 2 digits. This cannot be 3, 6. So I'm going to put 1, 2, 5, 6 there. Sorry, not 3, 4. I keep saying 3, 6. 3, 4 is what I mean. This can't be 3, 4. This can't be 3, 4. This could be 3, 4. So could this. So could this. This cannot be. So this is 1, 2, 5, 6. This is 1, 2, 5, 6 because these two are in the same box. This could be 3, 4. This could be 3, 4. This cannot be 3, 4. So this is 1, 2, 5, 6. This could be 3, 4. 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 Okay. So there's not a whole lot of that restriction going on here. So I'm not really sure how to restrict 3, 4 further. Okay. What else? What am I missing then? 5, 6 is going to be interesting. Yeah, maybe we think about where 5, 6 goes in this row. Is that? I'm not sure I can. I'm not sure I can argue this. I was going to say that this would have to be, if these were high, this would have to be 5, 6. I don't think that's true. We could put a 4 over here. If this ends up a 4, we get a 1 here, and then this has to be a 2, 3 pair. If this ended up a 4, this would be a 1. Oh, that's interesting. Okay. So can this be a 4 is the question. And the answer is no, because 4 has to go next to 1, but then we then have to put a 4 here to make them add to 5. So this can't be a 4. Does 3 have the same issue? Well, we can't put a 3 here at all because this can't be 6. So this is not 3, 4 either. This is 1, 2, 5, 6. I think that's helpful. Right? It can't be a 3 because that would force a 6 here, and this can't be 6. It's on a 5 sum. If this can't be 4 because that would force a 1 here, and then this would also be a 4 in the same row. So what does that mean for this column? That means that this where does the green 3, 4 go? There's going to be a green 3, 4 and a purple 3, 4. Well, the green 3, 4 can only go here. And that's going to be next to a purple 1 or 6. So these are both 1, 6. And they're the same digit as each other. They're both the purple 1, 6. Does that help me enough to continue? Well, it does mean this is 1, 2, 5, 6, just because it isn't the green 3, 4. So this is the green 3, 4 up here. This is a 1, 2, 5, 6. Now, interesting. So if this were the green 3, 4, this would have to be the purple 1, 6. Now we'd have 2 purple 1, 6s in this column. Basically what we can say is that these are 2, 3, 4, 5, right? So this cannot be a 1 or a 6, meaning this can't be 3, 4. So this is from 1, 2, 5, 6. And now we have proven that 3, 4 do not go here. And I think that's very important because my question is, where do 5, 6 go in this row? Well, if green happens to be high, then 5, 6 end up exactly here. What if green were low, though? Then we have 1, 2 here, 3, 4 here. That actually doesn't work. Okay, so that's even nicer. So imagine that this was not the 5, 6 pair, and this was instead a 1, 2 pair. This would then be a 3, 4 pair, but that doesn't add to 5. So that's not possible. So we've actually proven that green is high. So I'm going to go and change my green to orange, because I like to use orange for high, and my purple for blue, because I like to use blue for low. Now we get a bunch of cleanup here and some digits. So this is 5, 6. This is 4, because the 4 is the high. This is 5, 6. This is 5, 6, 5, 6, and 5, 6. This is 4, because it's high. This is 1, 2. This is a 1. This is a 1. That can't be 1. That can't be 4. That means this is low, so it has to be a 2, 3. Yeah, because it can't be 1 anymore. So this has to be a 2, 3 pair. So they're both low. Okay. And then this is a 2, I guess. These are a 1, 3 pair. This is 2, 3. I don't think I can restrict this one. This is a 2, 3 pair. This has to be a 3 for the row. So that's a 2. So that's a 3. That's a 2. So this is 1, 3. Now, 2 can be next to 5 or 6. That doesn't restrict this. Okay, what can we do from here? Here we've got 2, 5, 6. We know the 2 is in here. Can I restrict any of this more? 4s, 5 or 6, 5 or 6. Okay, if this was a 3, this would be double 6. Is that a problem? That would make that 5. That would make that 5. That would make that 6. I mean, it resolves a bunch of stuff, but I don't think it's a problem. If this was a 2, that doesn't help this at all. If this was a 3, this would be double 6. Again, I don't see why that would be a problem. I guess this is orange. Let's actually color that. One of these has to be a 4. Ah, this 3. There we go. This 3 does make this a 6. Okay. So that makes that a 5. That makes that a 6. We get a 6 here as well. We get a 2, 5 pair here. Ah, we get the 5 and the 6 here. Right, 3 needed to be next to double 6. I don't know how I missed that. That's 5, that's 6. We get the 2 and the 5 here, so that's low and that's high. This could be 3 or this could be 3. We actually are not restricted in that way. This is a 4 though. Oops, not green. That's 4. We need a 5 in here. This is the only place for 5 in the box. So we get these colors. This is 1, 2, or 3. I guess I'm not going to mark that as 1, 2, or 3. Do we get more colors? This is a 1, 4 pair. Ah, and this can't be the 1. So we get the 4 and the 1, and we do color them. That's orange, that's blue. Let's fill in these pairs here. So we need a 3, 4 here. The 4 tells us the order. So that's the 4, that's the 3. So that's orange and that's blue. We get our 2 here. This is an orange 6. This is a blue 2. So this is 1, 3. All right, I think we're finishing up here. Up here, we do need a 3 and a 5. We know the order. That's 3, that's 5, because that 5 there, that's 1 and 3, 1 and 3. Let's make sure we color this. All right. Coloring is done. That's our 4. That's our 1, and we're done. Correct solution. Very nice. That was really interesting. The interaction that this V did a whole lot of work, which was neat. Quite enjoyed that. So, and there were surprisingly few cells along this squirrel's tail that couldn't be 3 or 4, which was interesting as well. But there were just enough that we figured out these couldn't be 3 or 4. And that really did it. We were off to the races after that. So that was really neat. Thanks, Palfly. That was a cool puzzle. I really enjoyed that. Hope you enjoyed it as well. If you did, then why not leave a like, subscribe, and a kind comment below.